Hello and welcome to another example of our statistics introduction course, where we are looking at an example with ANOVA, analysis of variance. Now, you should have already watched the earlier videos in the playlist where we discuss the concept behind ANOVA, and we also work through an example by hand on a hand calculator. All we're going to do really in this video is do another example by hand, but we're going to use a spreadsheet as a more efficient calculator. We're not going to use built-in data analysis functions really. We're just taking advantage of the fact that with a spreadsheet, our calculations can be laid out and seen and organized better. We are very much still calculating the formulas just with spreadsheet software like Excel. I can be a little bit more efficient in doing that. So we are looking at the book Statistics for Psychology for this example. This may not be your prescribed textbook. That's perfectly fine. It's just one I have available. And we're looking at page 368 for number 18. And let's read that together first. And then feel free to pause if you want to read it again and more. We're not going to do necessarily every part of this, but we'll do enough to get the idea across. So these are long questions. They're going to take some time, but I don't want to go too fast for these, which are our first examples. Still, all right. A psychologist studying artistic preference randomly assigns a group of 45 participants to one of the three conditions in which they view a series of unfamiliar abstract paintings. The 15 participants in the famous conditions are led to believe that these are each famous paintings. Their mean rating for liking the paintings, 6.5, standard deviation. The 15 in the critically acclaimed condition are led to believe that the paintings are not famous but very highly thought of. Their mean and standard deviation. The 15 in the control condition are given no special information about the paintings. And there are the mean and the standard deviation. We want to see or ask a question: does what people are told about paintings make a difference in how well they are liked? We're going to use the hypothesis testing procedure and so on. So we have three groups, and we want to know if there's a difference between them in terms of their average rating. So we have for each group our mean and our standard deviation. We're going to need the variance, where we'll just square the standard deviation. I use a system where yellow cells represent input cells of given information, and green cells represent calculation cells, where I'm going to do some calculations. That just helps me to keep track of things. It's not absolutely necessary. Alpha here in the bottom is also given, so I guess technically that should be yellow. So let's calculate a variance estimate. So we'll start with an equal sign. We're going to take the standard deviation, shift 6, and square it. Enter. And the beauty of using a spreadsheet is I don't have to type everything in from scratch. I still need to know what the calculation is. I can double click on it and see that it took the, it took the cell above it and squared that value. If I now right click and copy and paste it over here, double click on that, I see that the cell that it used was relative to where I did the calculation. So I can copy it and paste it again. Oops, I want to copy this one, paste it over there. And I see it works every time. So I type in the calculation once and I can exploit the functionality of the spreadsheet to be more efficient. Yes. So my total degrees of freedom will just be adding up all the sample groups and subtracting 1. So we'll just do that in our heads. That'll be 45 minus 1. Within each group, I have degree of freedom 15 minus 1. But the degree of freedom that I'm going to use in my future F distribution is going to be that times 3. So I'll maybe do a calculation there just to do it for fun. 3 times the 40, no, not 41, 14. That's going to be the degree of freedom that's used in my F distribution later. So n minus 1, n minus 1, n minus 1 for each group. The degree of freedom between the groups is the number of groups minus 1, so that will be a 2. And now we have for our F score, we can go to the front of this book, has some formula sheets to help me because I don't have to memorize all these formulas. Usually you get a formula sheet. Let's start from the back, I suppose. Here, the F distribution and the F score that we're going to calculate. We'll use the variance between the groups and compare that to the variance within the groups. Estimates, of course. So we have to calculate each of these. So the way I've laid it out here, we'll start with the between group one. That is going to require that I look at the, like it said, variance between the groups. So I'm sort of treating the groups as one data point, one score, and I'm looking at the variance between them. So I'm looking at the mean of all of these, which we'll call the grand mean, simply the mean of means. And then we're going to calculate that with an average, where I will add up this guy, and this guy, and divide it by 3. The average function does that automatically. I could have also typed it in manually. Add all of this one, and this one together, divided by 3. The arithmetic mean, the average, now between the groups. Then we want to calculate the distribution, or the variance estimate of how these means are distributed by looking at the square deviations from this grand mean. So my mean for each sample is sort of like the data point, and then divided by the degrees of freedom between, which is the number of groups minus 1. So we need to calculate the square deviations from the grand mean. So I'm going to start my calculation, and my mean is my data point, if you will. Subtract the grand mean, and then close my bracket and square that. Now, technically this was a green cell if you want to be consistent with your labeling here, and this one will be the next one, and this one will be the next one. I have to calculate the deviation scores in each case for each group. Now, I've typed it up here, and I want to copy that over. If I do that now, just to illustrate some spreadsheet stuff, I see that, yes, it did take the mean from that group, but it didn't subtract the grand mean. It was over here. It moved everything relative to the cell I'm in. So I can go back to this one and say, okay, well, this B13 pink or red cell, I'm going to press F4, and then it puts dollar signs there indicating that that cell shouldn't move when I copy stuff. So if I now copy and paste I can see here that it used its mean score for that group, and the grand mean is fixed. So I can copy that again, move it over here. Same thing happened. It moved the correct cells and fixed the correct cells. A little bit of efficiency there that I can use with a spreadsheet. Rather than tediously typing in every calculation on a hand calculator, I'm still doing the same things, just more efficiently. So then I'm looking for a calculation, the sum of this guy and this guy and this guy. And I'm going to divide that with the number of groups minus 1. That's the degree of freedom of the between groups degree of freedom, or degrees, I guess. All right. So that is, however, a variance estimate that refers to a distribution of means. My F-score compares variance estimates referring to individual scores. So I have to convert that a little backwards. In the t-distribution discussions and examples, we had the individual score version, and we had to calculate the variance of the distribution of means by taking that guy and dividing by the sample size. Here, we're going to do it a little bit backwards, taking the variance of the distribution of means estimate and multiplying it by the sample size. So we're going to take this previous cell and multiplying it by the size of a sample. And we get our variance estimate for the between groups variance estimate. Lastly, I'm not sure if there's a formula here. No, there isn't. To get the F-score calculated, I also need an estimate of the variance within the groups. Now I have a variance for each of the groups, and in that case, to get a better estimate, I'm just going to average these out. Now let's suppose, I know what I want to do, but I'm not sure what the function is. You can go up here and insert a function and search. I think I want to calculate an average. So I'm going to go and search for average. And there's a bunch of options here with descriptions, and you can find that that first one is the one I'm looking for. And then it also guides me through, what do you want to average? Well, I want to average the variance and this variance and this variance. And it will, oh, why did I put it over there? That's unfortunate. And it will add them up and divide by how many there are. Let's just do it in one line. Average of this one and this one and this one. So you do have options. If you can't quite remember what the function names are, you can search for them as well. So now the F-score we can calculate as the between groups estimate divided by the within groups estimate. So that's a very simple calculation. Whoopsie, not Alt. Where did I press Alt? Get away. Equal sign, between divided by within. So my F-score is that guy. Let's visualize that. Now this is, maybe I forgot to mention, the hypothesis test, or the hypotheses here in my hypothesis test. The null hypothesis is that all the means are the same for the populations, the respective populations. And the research hypothesis is that some things they're not all the same. Maybe it's just two of them that are different. Maybe all three of them are different. I don't necessarily know at this stage. I'm just trying to establish, is there evidence to suggest it is different somewhere? So my F distribution is what we're going to use. Let's visualize that over here. That's somewhat of a straight line. So we have our F distribution, something like that. Just a rough visualization, right? It's always a one-tail test. So my F score is currently sitting over here somewhere. So let's call that F observed, and that is 8.76, we'll say. All right. No, I lost it. Oh no, it's gone. Well, we're going to redraw it in a second. Let's first calculate the cutoff that we need to compare that to with the degrees of freedom between and the degrees of freedom within. Now, normally you can look in a book for a table of all the F distribution values, but spreadsheet software like Excel has that built in and more accurately as well, because the book often has to summarize it for space reasons. Except I don't want to put it there. I want to be in that cell. So I'm going to go search. I'm not sure what the function is called. Let's search for F distribution. I know it's very small there. I can't make those bigger. And there's a whole bunch of distributions. We're going to go down to F. So the F distribution will take an X value and give me the cumulative probability. We want the inverse of that. It says left-tailed here. It should always be right-tailed. So it's going to take a probability and the 2 degrees of freedom to give me what that cutoff is. So my probability is 0.5. First degree of freedom is the 2, the between, and then the within. So I just reference the cells that have them all already stored. 3.22-ish. So now let's visualize this again. I lost my first drawing, but that's okay. In a test, you usually have to have a rough drawing of what this looks like. Something like that. So we had our observed, F observed here at 8.76-ish. Our cutoff, let's make it green, sits over, let's put it over here. F cutoff, 3.22, let's say. So that this area over there is my alpha of 5%. So now the evidence suggests that the ratio of these between and within groups variances are quite extreme, that if they were all the same, we would expect some variation, sure, but nothing that extreme. Though it isn't impossible, it's very unlikely to get. So we'll conclude that that is strong enough evidence to suggest that there's probably some difference here between the groups. So let's write that down. Now we can write that down in a variety of ways. We'll just start by saying since F observed is greater than F cutoff, we're going to reject the null hypothesis. It's also good to rephrase that in words that the question used. So the question was on page 368. I know I'm writing on the screen there, but hey, we can look past it. Number 18, what was this about? This was about being told different information. different information about the paintings and then rating. What was the rating about? Just how they feel about it? Why can I not find it? Rating for liking the paintings. So now in these words, we can say it a little bit more casually. The evidence is strong enough to suggest that there is a difference in, let's say, the liking scores or ratings depending on the information provided to the people. Something like that, right? Something that refers to the actual problem. Because very often the person that has this question, they're not that well versed in the statistical analysis language that we're using. They just want to know the answer. Is there a difference here? So just saying, oh yes, we reject the null hypothesis, they don't understand what that means necessarily. So you have to be able to explain things in a different, in different levels, on different levels, with different languages in a way. So what is our, let's get rid of this picture. I think we're done with that. We have another question here. We've sketched it. Effect size, yes. Oopsie, I'm still in the drawing mode. There we go. Effect size. Now, that is not on the formula sheet, but it is in your book. In this book, it's on 345. Is that page 345? That is not where I want. Oh, down here. My effect size has different names. One is R squared, and there is the formula. I'm just going to drag this to my other screen so I can look at the formula as well, because it is a little bit more involved. But I'm just copying it. I'm just calculating it here. The between groups estimate times the degrees of freedom between, divided by two things being added together. So I'm going to have some brackets there. I'll go inside the brackets. Then it's the same one. So the blue times the pink, plus the within groups estimate times the within groups degrees of freedom. There we go. Let's move that back in case I need it later. And we get a 0.29-ish. Now that I'll show over here. Let's just interpret that here. Is the proportion of the total variation of scores from the grand mean, so between the groups, accounted for by the variation between the groups and not within, because there's always going to be some variation within. How much is accounted for between the groups? Now, because our evidence was strong that there is a difference between the groups, some of the variation we observe comes from that between the groups variation, as well as naturally within the groups. So I'm looking for a table here to just classify the effect size. Our group size, our number of groups rather, was 3. So we have, what did we? 0.29. 0.29. What is this? Participants per group. We had 15, so we're between 10 and 20. So we're still in the medium effect size range here. So we'll say here, medium effect size. All right, good. Then I believe on page 368, there was a further question, number 18, for some planned comparisons. We're going to skip D. not write out all the words to explain it, because we're sort of saying that as we go. We want to test the significance of planned contrasts. We're not going to do all of these. We'll just do the first one, famous versus control. There are other questions like for post hoc comparisons or contrasts with a Bonferroni correction. We're not going to be able to do all of this in this video. We'll just do a planned contrast. Famous versus controlled, real quick.
Welcome to MathCats, where we aim to better understand mathematics. Join us weekly for discussions on elementary, high school, through to university math. You can request the next topic by leaving a comment on our YouTube channel or by emailing us at mathcats314@gmail.com. And as always, remember to like and subscribe. Thank you.
So when we're looking at famous versus controlled, I'm just going to move this so we can see them side by side. Let's say over here, maybe. Yes. Make that bigger. Okay. So when we're looking at famous versus the control group, our grand mean is going to use just those two. We want to see if there's a difference between those groups specifically. So we can't let the grand mean be affected by the critically acclaimed group, which could be the one that is different and affect things. So very similar to this, I'm just going to copy the, I don't know if I can copy it. Sure, I can go. Well, let's look at this first. What was the grand mean calculation? It was just averaging all of them, but now we're going to average equal sign. No, I don't want to open anything. Equal sign. To start my calculation, I'm going to average just the two in question, which is famous and control. Close my bracket. There we go. Between groups, degrees of freedom was the number of groups minus 1. Now it's going to be 2 minus 1. The variance of the distribution of means estimate used the square deviations for all the groups in question divided by the number of groups minus 1. Now we'll do the same thing, but just for the groups that we're investigating. So we're going to add up the square deviations for the famous group and the control group and divide that by the degrees of freedom. I know that's just 1, but still. And we get our updated value. Then remember that the between groups variance estimate took that previous variance of the distribution of means and multiplied it by the group size. We'll do the same. Take that, multiply by the group size of 15. So we get our first part of the F, or the top of the F score calculation. Within the estimation for the variance within the groups, under the null hypothesis, we assume they're all the same. We will take the best variance estimate, which is still the same as before. So it'll still be this 12.7. So I'm just going to put it in my list and just reference this. No new calculation because we've calculated it before. Now my F score is between divided by within. Why did it not like that? Oh, not the actual words. Yes. Between divided by within. And I get a 10.3655. My alpha is the same. It's a planned contrast, not post hoc. my cutoff is going to be this. Oh, it's not a 2 now, it's a 1. The degrees of freedom between have changed. So we're going to have to go and look that up. What is my cutoff now? Well, I have the recently used functions in this list, so I don't have to go and search for it again. It's right there, F inverse right-tailed. My probability is 0.05. Degrees of freedom is the updated 1. Other degrees of freedom is the same, the 42. The within groups estimate doesn't change, so I get a 4.07. Now we can draw it again, but we see that the F observed is greater than the F cutoff. So I'll just copy this. It's the exact same, but our null hypothesis was, I guess, technically different here, right? Null hypothesis. No, I copied it. Copy, paste. Null hypothesis was between groups 1 and 3 only. So we can say here that the evidence is strong enough. Evidence, or let's just say suggests that there is a difference in rating when people are told it's from a famous artist. So you can use your own words here, but I want to be able to not only make the conclusion in terms of my hypothesis testing language, but also in the language of the question. All right. So that was us working through another ANOVA example, sort of by hand, with the luxury of a fancier calculator, really. But it's definitely not using statistical software to do it for me. Still have to know the formulas, how to use them, and so on.